For 21 episodes, we've been mapping and reading targets. Today, we finally attack, and we're starting with the single most important, most impactful class of vulnerability in all of web security: injection. It's the flaw behind some of the largest breaches in history, and it still sits at the very top of the industry's risk lists. The idea is deceptively simple. What happens when the data you send to an application gets mistaken for commands? When your input stops being just input and starts being code the server actually runs? Click injection. Let's break something. Click courage. Last episode, you fingerprinted the exact technology behind a target, its server, its framework, its database. Now you use that. Injection is where you take an input the application trusts, a search box, a login field, a URL parameter, and you slip in something it was never meant to accept. Recon told you what the machine is made of. Injection is you reaching in and pulling a lever it didn't know was exposed. From here on, everything we do is exploitation. This is the first door. So what is injection precisely? Almost every web app takes your input and feeds it into some other system. A database, the operating system shell, an interpreter, the HTML sent back to a browser. The application builds a command or a query and drops your input right into the middle of it. Injection happens when you craft that input so it breaks out of the data part and becomes part of the command itself. Suddenly you're not filling in a form, you're writing instructions that the back-end system faithfully executes. One input and you're speaking the machine's language. The root cause of every injection bug is the same: mixing data and instructions in the same channel. When a program builds a command by gluing trusted code together with untrusted input as plain text, the boundary between the two can blur. If the system can't reliably tell where your data ends and its own instructions begin, you can cross that line on purpose. Every injection type, no matter the technology, is a variation of this one mistake. Understand that principle and you understand the entire family at once. Let's start with the classic SQL injection. SQL is the language applications use to talk to their database, to fetch users, check passwords, and read records. When a site takes your input, say a username, and builds a database query by pasting that input straight into the SQL text, it becomes injectable. You send input that isn't just a username, but a fragment of SQL. The database can't tell the difference, and it runs your fragment as part of its own query. Now you're talking directly to the database. Here's the mechanic. Imagine a login query that looks up a user where the username equals whatever you typed. Normally you type a name, but what if you type a single quote, then space, or 1 equals 1, then a comment marker? You've closed the original string early, injected a condition that's always true, and commented out the rest. The query now returns every row, and the app may log you in as the first user, often the administrator, with no password at all. That tiny payload just walked past authentication. SQL injection comes in a few flavors based on what the app shows you back. Error-based, the app leaks database error messages and you read the data straight out of them. Union-based, you use the SQL union keyword to append your own results onto the page, pulling out whole tables. And blind injection, the app shows nothing useful, but its behavior changes. A true condition loads the page, a false one doesn't, or it responds slower when you tell it to wait. Even with zero visible output, you can extract the entire database, one yes or no question at a time. Doing blind injection by hand is slow, so we automate with SQLmap. SQLmap is the industry standard SQL injection tool. You point it at a vulnerable parameter and it automatically detects the injection, figures out the database type, and then extracts everything: the databases, the tables, the columns, and the rows. It can dump entire user tables, crack password hashes, and in some setups even read files or get a shell on the server. It is extraordinarily powerful, which is exactly why you only ever run it against targets you are explicitly authorized to test. Why is SQL injection so feared? Because the database is the crown jewels. A single SQL injection flaw can expose every username and password, every customer record, every credit card, every private message. It can let an attacker bypass login entirely, modify or delete data, and sometimes pivot to full control of the server. Some of the most catastrophic data breaches in history came down to one injectable parameter. One overlooked input field and the entire database walks out the door. Now a different, even more dangerous cousin: command injection. Some applications pass your input into a system shell command, maybe to ping a host, convert a file, or run a utility. If they build that command by pasting your input in as text, you can inject shell commands of your own. You add a semicolon or a pipe or the and operator followed by your command, and the server runs it. Type something like a semicolon, then who am I, and the operating system executes it. Command injection often means direct code execution on the server. The most severe outcome there is, just like SQL, command injection can be blind. The application runs your command but never shows you the output. So you get creative, you make the server prove it ran your command by reaching back to you. You inject a command that pings a server you control or makes a DNS lookup to your domain. When you see that connection arrive, you've confirmed code execution even though the page told you nothing. This out-of-band technique is how blind injection of every kind gets confirmed. Make the target phone home. The next huge branch of injection targets not the server but other users. It's called cross-site scripting or XSS. Here, the interpreter you're injecting into is the web browser and the language is JavaScript. If an application takes your input and drops it into a page without properly encoding it, you can inject your own HTML and script. When another user loads that page, their browser runs your JavaScript as if the site itself wrote it. You're no longer attacking the server, you're attacking everyone who visits. XSS has three main types. Reflected, your payload is in the request, and the server echoes it straight back into the response, so you trick a victim into clicking a crafted link. Stored, your payload gets saved on the site in a comment, a profile, a review, and it fires for every single user who views it, far more dangerous. And DOM based, the injection never touches the server at all. It happens entirely in the browser's own JavaScript mishandling your input. Reflected, stored, and DOM, three routes to running your script in someone else's session. What can you actually do with XSS? Your script runs with the victim's privileges on that site, so you can steal their session cookies and hijack their logged in account. You can log their keystrokes, capture what they type, rewrite the page in front of them, redirect them to a phishing clone, or perform actions as them silently. Stored XSS on a high traffic page can compromise thousands of users at once. It turns a trusted website into a delivery mechanism for your code running inside every victim's browser. SQL, command, and XSS are the big three, but the injection family is much larger because the principle is universal. There's SSTI, server-side template injection, where you inject into a templating engine and often reach code execution. There's XML, external entity injection, that can read server files. There's LDAP injection against directory services and header injection against HTTP responses. Anytime an application builds a command or document from untrusted input, injection is possible. Learn to see that pattern and you'll spot injection points everywhere. So how do you actually find injection? You test every single input and there are far more than you think. Form fields, URL parameters, HTTP headers, cookies, JSON and API requests, file names, every place data enters. Into each one you insert broke characters that would break a command, a single quote, a double quote, a semicolon, angle brackets, curly braces. Then you watch the response. An error, a change in behavior, or your input reflected back unescaped, any of those is a thread to pull. You're systematically poking at every boundary, looking for one that gives. Your primary tool for this is Burp Suite, specifically the repeater. You capture a request, send it to repeater, and now you can modify any part of it and replay it again and again, watching exactly how the server responds to each payload. Change one character, resend, read the difference. This tight manual loop, tweak, send, observe, is how real injection bugs get discovered and confirmed. Automated scanners help, but the deep, high-value findings come from a human patiently probing one input at a time in repeater. Now, the other side, because a great hunter understands the fix. Injection is prevented by never mixing data and instructions. For SQL, you use parameterized queries, prepared statements, where the query structure is fixed, and your input can only ever be data, never code. For command injection, you avoid the shell entirely and use safe APIs or strictly allow list input. For XSS, you encode output for the exact context, so a browser treats your input as text, not markup. The universal rule, treat all input as untrusted and keep it strictly separated from your commands. When you report an injection bug, you recommend exactly this. A few tips to test well and stay safe. 1. Be systematic, test every parameter because the vulnerable one is often the header or cookie nobody checks. 2. Understand the context. The same input behaves differently inside SQL, a shell, or HTML, so tailor your payload. 3. For blind bugs, master out of ban, make the target call home. And 4. The big one. This is powerful, real-world, damaging stuff. You run these techniques only against systems you own or are explicitly authorized to test. Injection on someone else's site without permission is a serious crime. Step back and see why injection is the perfect place to begin exploitation. It's everywhere. It's often devastating, and it flows directly from the recon you already learned. You fingerprint the database, then you inject into it. It rewards exactly the mindset we're building, seeing an application not as a set of pages, but as a set of systems processing your input, each one a potential boundary to cross. Master injection, and you internalize the core instinct of all of web hacking. Never trust the boundary between data and code. So that's injection, the whole family. From one simple idea, untrusted input becoming code. You've now got the map of the most important vulnerability class in web security. Next episode, we go deep on the most famous member of that family, and we get hands-on, full SQL injection, step by step, from finding it to dumping an entire database with SQLab in a safe, legal lab. This is where it gets real. Subscribe so you don't miss it, and tell me, which injection type do you want to see broken down first? See you in the next one.